Good afternoon, everyone. And my name is Beninfo Ebenezer. I'm a RAN engineer. Okay, so by way of introduction, as I said, I'm a RAN engineer. I've been in the industry for at least 12 years. And I do integrations, I do support, I do operations and maintenance. Yeah, but what I love or what I enjoy doing is integrations. Yeah. Okay. So I've worked on a lot of projects across the continent. I've worked in Ghana. I've worked on MTN network. I've worked on Tigo, Senegal, Tigo, Tanzania, Zantel, MTN Cameroon, MTN Liberia, Guinea-Bissau, Etel Niger. Yeah, I've done quite a lot when it comes to RAN. So I love doing RAN, and RAN is one interesting part or segment of the mobile telephony network. So within the next 1 hour, I'm going to try to introduce to you what the access network architecture is all about. Yeah, and the various types, Yeah, I must say that the slides were put together by a colleague of mine by name Douglas Kofi. Yeah, sure. In due course, you're going to know him. Yeah. So I want to acknowledge him for the great job he did. So let's move on, Max. Let's get to the next.
Okay.
Yeah.
Can you see the next screen?
Not yet. You're loading, I guess.
Yes, I can see from here.
Yeah, I can see it.
Paul, we are waiting for you. Can you see from your side?
Yes. Okay, just came. Right. Okay.
Okay.
Straight to explain what the radio access network is. Yeah, so the radio access network is a portion of the telecommunication system that connects specific devices to other portions of a network through radio connections. Okay, so I guess you can all read what is on the slide here, but what I can say here is, that mobile telephony has been put into various sections. I guess you just finished one portion or one section, which was iron. The radio access network is also another portion. This is the part of the network that interacts directly with the user equipment or to the end user. Right. It's made up of some nodes or some equipment. Okay. So when you say radio access network, currently we have 2G, the second generation. We have 3G, which is the third generation. We have the 4G, which is the fourth generation. And I believe we are all aware we are anticipating the launch of the 5G, right? Yeah, and all these are based on different technologies, right? Okay, so a RAN sits between the user equipment, such as a mobile phone, a computer, or any remotely controlled machine, and provides the connection to the core. So when you pick your phone or your tablet in your car,
Hello?
mobile telephony
your
network
voice is breaking.
or a mobile network. Your
voice is breaking.
connection, yeah.
The connection is breaking.
Voice is breaking. Hello, Maxi.
Yeah.
Is it better now?
Hello.
Is it
It's
smoother?
better, but it's still raspy. You
Yeah.
can go ahead. Just go ahead.
Okay, so the radio access network connects the user equipment to the core network. So I would say is a bridge, or is a connection between the user equipment and the core network. Okay, so the RAN is a major component of the wireless communication, telecommunication, and has evolved through the generations of mobile networks leading up to 5G. So that's what I said, that initially, I mean, we had the 2G, what we call 2G, which is the second generation. As when we came to the digital, or the analog, we will not even talk about that. But when we got to digital, we have the 2G second generation, 3G third generation, 4G fourth generation, and then now we move to the fifth generation. That is what we are. And I mean, there have been some tests, and even in some countries, 5G is already being rolled out. But in our part of the world, we are actually waiting for the commercial launch of the 5G network. Yeah. So let's move into the types of RAN. And I guess the type is also based on the generation or the type of technology which was deployed. So we have the GRAN. GRAN is simply the GSM radio access network, right? And then we have the GE-RAN. Okay, so the GE-RAN and the GRAN is, I mean, they are mostly, or they are largely the same, but the only difference between the GRAN and the GE-RAN, I would say, is the data throughput, because the GE-RAN has the inclusion of the edge and enhanced data rate for GSM evolution. That is the edge, where you have higher packets radio services in terms of the throughput. If you're on a network which has edge, if you're on a 2G network which has edge, your data throughput is higher. I mean, compared to a GRAN where there's no edge. You understand? So the GRAN and the GE-RAN, they are basically the same, but the GE-RAN has the packet radio services included. Yeah. So initially, the GSM RAN or the GRAN was just for voice. There was no data services that came with it. Now there was an improvement where they put the GPRS, and then later the EDGE, which is the edge, enhanced data rate for GSM evolution. So now the GE-RAN is just like GRAN, but there's packet radio services included. Okay, so the other type, or another type of RAN we can talk about, is the UTRAN, the UMTS terrestrial radio access network. Okay, so this one supports circuit switched and packet switch. When you say circuit switch, it's just for voice. I mean, the voice services is called the circuit switch, and the packet switch is for data. Okay, so we have the EUTRAN, that is the evolved universal terrestrial radio access network. That is also UTRAN, but it's involved. It's enhanced in the sense that the data rates, for the packet radio services was improved. Yeah, because the main reason the UTRAN came was to improve the data rate or the throughput when you are accessing packet switched services on the network. So the EU TRAN was to enhance the amount of packets that can the amount of packets that can go through the network. So it's all about data and the data throughput. So this point, I'll pause a little, just maybe for 2 minutes. If you have any question at this point, I'll entertain it so that we move together. I believe this is something a lot of us know already. Yeah, and the motive or the intention of this series is just to give you an overview. But at Televersity, we want to give you the practical knowledge, not just the theoretical part, the practical knowledge that will make you marketable in the job market and also give you the skill to work when you are employed, right? So I would want this whole presentation to be as interactive as possible. So at this point, if you have any question, just bring it out and let's see how we can all learn at this point before we continue.
Yeah, hello, Eben.
Yes.
Yeah, my name is Eben. This is a very quick one. I don't know if the question is very early, but I want to know if you want to become a RAN engineer. You know, you started from 2G and now we are anticipating for 5G. And do you have to start from somewhere, or you can just combine all the four together and then become one, or you just have to move at a particular piece?
Your network is your voice is not very clear. I mean, check your network and then come again with a question.
Am I audible now? Can you hear me?
It's a little better. So go on. Let's see.
Okay, so I was saying that if you want to be a RAN engineer, right?
Yeah.
You know, we started from 2G and now we are anticipating for 5G.
Yeah.
So what I wanted to know, or I want to know is that do you have to be all of them, be at all cycle, or you just have to take one at a time, master it, and then you proceed to maybe the next technology?
Yes, that's a very interesting question, very important question. Okay, for instance, I started out as a 3G engineer. I was employed. I was employed in Huawei. That was in 2007, right after my service as a RAN engineer. The project was supposed to be 2G, right? But we were too many, so I was moved to the 3G network. I mean, the 3G project, which was new, right? So I started out as a 3G guy, 3G RAN guy. I didn't know much about 2G. Then I moved to 4G because, I mean, from 3G to 4G is quite easy, or it's similar. The technology is similar. So it's easy to move from 3G to 4G. So I started out from 3G to 4G. But at a point, I realized that I know the 2G too. So I had to go back and also learn the 2G. And I must say that since they are all RANs, the technology, the things are very similar, right? It's just that the equipment you work on that are different. Yeah, for instance, if you are a 2G RAN guy, you work on the BTS, which is on site, which is on a cell site, and then the controller, which is the BSC for 2G. Now, if you're working on the 3G, the controller is not BSC, it's RNC. It's also a controller. So you see, even if you are a master of 3G, 2G, it's a bit easy to learn the other side of it, right? You understand?
Yeah, I get it. I get it.
Yeah. So you need to know a bit of everything, but of course, you will be a master of, say, 2G or 3G or 4G. For instance, I know 2G now, but I am more comfortable working on 3G and 4G. So that's where I started out, and I've done a lot more in 3G and 4G runs. You get a point?
I get it. I get it.
Yeah. Okay. So do we have any other question, or we move on?
Eben. Hello, Eben. Hello, Eben. Hello, Eben. Hello, everyone. Can you hear me?
Yeah, we can hear you.
Yeah, Eben.
Hello, Mark.
Eben.
Can you hear me now?
One thing, we can hear you. Can you turn off your video? I think it's taking out a lot of bandwidth. It's churning out a lot of bandwidth. So just
let me try to do that. Camera is off. Okay, so my camera is off now.
Good. Yeah.
Is it better?
I think you have enough bandwidth. Yeah. Good.
Okay, so functions of the RAN. Interesting. So a RAN provides access and organizes the management of resources across the radio and other devices wirelessly connected to a backbone or core network. Okay, and the RAN sends its signal to several wireless endpoints, so it can travel with other networks traffic. As a single handset or phone could be connected at the same time to multiple RANs, sometimes called dual mode handsets. Of course, we have a lot of these phones where you can put in SIMs from 2 different networks. So you are connected to MTN RAN, you're connected to Vodafone RAN, for instance. Okay, so basically, if I will summarize this part, I always see the RAN as the part of the network that gives access to the user, right? So it's a bridge between the user and the core network. You know, there are a lot of nodes and a lot of things happening at the core network side. Yeah, and those are mostly invisible to the user, but the RAN is the part that is mostly visible to the user, because the user connects directly. That's the first point of contact to the network. Yeah, so if you go to a cell site, at least everybody knows a cell site where you see the tower, you see the antennas and everything. These are all parts of the RAN network. So the end user sees this, but the core network, whatever happens there, nobody sees all these nodes. Yeah, but the RAN, for the equipment in the RAN, some parts are visible to the end user. Okay, so the RAN's controller controls the nodes that are connected to it. So like I said, for 2G and 3G, one major component or one major equipment or node is the controller. The controller for 2G is called the BSC. Controller for 3G is called the RNC, right? So the RAN's controller controls the nodes that are connected to it. Okay, so on one controller, there are a lot of sites or cell sites which are connected to the controller. For instance, if you're talking about 2G network, the BSC has all the cells, all the cell sites connected to it, right? So it controls all the sites which are connected to it. If you pick the 3G, where the controller is the RNC controls all the 3G cell sites on the network. So every site is defined on the RNC. So if you connect to an RNC where you say where there are about 100 sites, you see all the site information there, and the sites are normally named, or they are labeled per the location or the cell IDs or the site IDs and everything. So for instance, if I connect to an MTN Ghana network at RNC, say 80 RNC1. 80 RNC1 is Accra Tetekwashi RNC1. That is how that controller is named. If I connect, I will see all the cell sites which are being controlled by 80 RNC1. So any changes I want to do to it, I can do. What the controller also handles something like what they call mobility management, like handovers. Yeah, for instance, if you are talking on a cell site at Pram and you are moving to maybe Dawenya, another cell site called Dawenya, your call should be seamless, such that you shouldn't know, you the end user shouldn't know that you are moving from Pram to Dawenya. So you should be seamlessly handed over from the cell site at Pram to Dawenya. It is the controller that manages all these. So the network controller performs radio resource management, mobility management, and data encryption. You understand? So the mobility management is what I explained about handover and all that. Resource management, if you want to make a call, you need channel to make the call. So it is the controller that determines or gives you or allocates a channel to you. So you can make a voice call or you can browse. So these are some of the functions of the RAN and the controller. So it connects to the circuit switched core network and packet switch core network, depending on the type of RAN. So for instance, the 2G RANs do voice and data, even though the data rates are low. On the interface, there are two interfaces that connect the core network, right? There are two interfaces that connect the core network. One interface goes to the packet core, and then the other one goes to the circuit switched core, right? So to us RAN engineers, if you are doing integration, for instance, if you have a new RNC you want to integrate into the network, you work basically on three interfaces, right? One interface is coming to the cell site. That is what we call the IUB interface, and two interfaces are going to the core network. So the core network, there are two. That is the packet core, what they call PCN, and then we have the circuit switched core. So if it's an RNC, you know, the interface that goes to the packet core is called the IUPS, and the interface that goes to the circuit core, circuit switched core is the IUCS. Okay, so go back to the last diagram. Max, please go back to the last diagram for me, the last slide. Okay, so this is a GRAN. This is a typical GRAN. It's simple, right? It's very simple and interesting. So like, as I said earlier, you see the user equipment or the mobile phone is connecting to a BTS site. This is a GSM RAN, right? So your mobile phone connects to the tower. The tower has antennas on it, and the antennas are also connected to some devices at the cell site, you know, which are all parts of the RAN. Okay, so between the BTS and the BSC, so this is a GSM RAN. There's a controller, and the controller is the BSC, right? That's a base station controller. Okay, so the interface between the BTS, which is on the site, and the BSC is called the ABIS. That's the ABIS interface. All right. Okay. Now, between the BSC and the core network, there are two interfaces. One is going to the MSC for voice or circuit switched services, and the other interface is going to the SGSN, which is the packet core network. So the main node which connects on the packet, which the RAN connects on the packet core, is the SGSN, and that interface, the GB interface, right? And the A interface is where it connects to the MSC, right, for voice services. Okay, so let's go to the next slide, please. Max, can we go to the next slide?
Yes, can you see it?
Okay, so there's something on the BTS, which is the base transceiver station. Okay, BTS houses the radio transceivers that define a cell and handles the radio link protocols with the MS. Okay, the BTS corresponds to the transceivers and antennas used in each cell of the network. A BTS is usually placed in the center of a cell. Its transmitting power defines the size of the cell. Each BTS has between 1 to 16 transceivers, depending on the density of users in a cell. Each BTS serves a single cell. Okay, so let me try to summarize everything we have on this slide. Okay, so the previous picture you saw the BTS where you saw the tower with the antennas. You know, there are other equipment down there. Okay, so can you go back to that slide for me before we come here? Great. Okay, so so the equipment which will be on the cell side will have the transceivers, which we call the TRX. This still 2G, so we have the TRXs. So the TRXs they are like the resources on the site. So if somebody wants to make a call, it is these TRXs which are made available to the user equipment, and then the person is able to connect to a channel and then make a call, right? The BTA is usually placed in the center of the cell. Transmitting power defines the size of the cell. So every cell has a coverage, right? A coverage where the signal can get to, right? So if you want to increase the power, if you want to increase the size of the coverage, one parameter you play with is the transmitting power, right? So the radio has a transmitting power. Every radio has a capacity it can transmit, right? So the hardware power capacity is there, and then you can also adjust, because maybe for a particular site you don't want to transmit at full power of the radio, because you don't want the cell to overshoot, to go beyond a certain range. So you tweak the transmitting power to define the size of the cell, to define the coverage area of the cell. Okay, so let's go to the next slide. All right, so the BTS also handles some functionalities like encoding, encrypting, multiplexing, modulating, feeding the RF signal to the antenna. Okay, transcoding, rate adaptation, frequency synchronization, voice throughput, full rate and half rate service, decoding, decrypting, equalizing, receive signal, random access detection, timing advances, uplink channel measurement. So these are all functionalities which are embedded in the equipment, which is called the BTS, which is on the site, right? So I must say the BTS is the first node that your user equipment connects to. So the BTS will be there. If you have the chance to visit a cell site, you see the BTS there. It's connected to the radio, and the radios are connected to the antenna, to the antennas, right? So these are all the functionalities of it. These are stuff you can read, but at Televersity we don't even focus too much on the theory. We want to see how you can get a practical knowledge to make you marketable, and then to help you work efficiently and effectively on the job. Okay, so let's go to the next slide. Okay, so we come to the controller. I think we've talked a little bit about the controller already, but this is the base station controller. That's the BSC. So it's a 2G node. That is the biggest node on the 2G RAN architecture. Yeah, so that's where all the controls happen. Yeah, it controls all the resources in the BTS. Yes, because all the BTS are defined in the BSC. For what purpose? The purpose is to control them. It also handles the radio channel setup. Everything that happens on the BTS is being controlled by the BSE. Yeah, and we've talked about stuff like mobility management, which is very important. How subscribers are handed over from one cell site to the other. We've also talked about stuff like resource management, how channels are allocated to user equipment or to users who need them to make their calls. Yeah, so these are all the functions of the BSE. The BSE is the biggest node in the 2G RAN network. Okay, so let's move on. Okay, so these are still some of the functionalities. These are stuff we can read. Yeah, so as a 2G RAN engineer, sometimes you can even be called a BSE engineer. Yeah, because you are basically working on the BSE. You're controlling everything on the BSE because the BSE is at the center of the 2G RAN. Yeah, so you cannot tell me you are a 2G RAN guy and you only know BTS, then you'll be called a field engineer. Yeah, but if you want to be the like a real RAN guy, then the BSE should be your friend. You should know your way around the BSE. Yeah, as a 2G RAN guy. So these are all the functionalities there. We can, and there are ways all these functionalities come to play. Yeah, I mean the ways all these functions are achieved on the RAN. Yeah. Okay, Max, let's move on. These are stuff we can read and understand. So now we come to the 3G UTRAN. Another interesting type of RAN. I love the UTRAN. Yeah, because it's been there for some time now, and it's in some countries it has replaced the 2G. In some countries like Japan, you will not see 2G network there because they've replaced or swapped all the 2G RANs with 3G and 4G. Yeah, so UTRAN came to actually improve on the data services because the world was moving towards data. I mean, the voice services was there, but we wanted to be able to browse faster, watch our movies, stream, and do all the nice things we've been doing, yeah, through the mobile telephony. Yeah, so the 3G came to improve the data throughput, which was being offered by the GSM network or the GRAN. Yeah, so this is a diagram of the UTRAN architecture. Let me try to explain it. The interfaces. Yeah, as a RAN engineer, you are supposed to know some interfaces. Some interfaces you are just supposed to know them because in interviews they will ask you, you know, and during your work you define, you do some configuration based on the interfaces. So the interfaces are very key to you. You're supposed to know them, understand them, and then it will help you in your work. So let's move from the user equipment as your phone to the hello, Matt.
Yeah, hello. Sorry.
Yeah. Sorry. So I want to explain this to
the diagram.
The diagram is very important. It's at the heart of everything. I want to take my time to explain to them. Yeah, so you see the UU interface. It is an interface between the user equipment and the BTS or the node B. Okay, so in 3G or UTRAN, the BTS is called node B. Okay, but in GSM it's called BTS. Now, when we came to 3G, they say it's not BTS again, we call it node B. That's the technical word. So the interface between the user equipment and the node B is called the UU interface. UU interface. W. Now, between the node B and the RNC, here on the 3G network, the biggest node that you need to love, that you need to work